In this video, we're going to talk about how to write systems of equations in 3 different ways. So to begin with, I have written down a vector equation. So here we have some scalar variables, x1, x2, x3. Each one of them is multiplied by a vector. We add them together, and we have this set equal to yet another vector. So to make sense of this in another way, we can use our usual vector operations. So we can multiply our scalars into our vectors and rewrite this as, say, 1x1, 3x1, and negative 4x1 for the first one, and similarly for the other two. And of course, that will still be equal to negative 1, negative 2, 0. And now we can apply vector addition. So we just add up each component. So on top, we get x1 plus 2x2 plus 3x3. In the second part, we get 3x1 plus 4x3. And in the bottom part, we have negative 4x1 plus 7x2 minus 5x3. And we're still equal to negative 1, negative 2, 0. Now, two vectors are going to be equal exactly when all of their components are equal. So what this tells us is that those first two components better be equal. In other words, x1 plus 2x2 plus 3x3 has to equal negative 1 for these two vectors to be equal. But also we have to have 3x1 plus 4x3 equal to negative 2. And we need to have negative 4x1 plus 7x2 minus 5x3. That needs to be equal to 0. So our single vector equality turned into this system of 3 scalar equations. Now the last piece of this is that we typically write these in the same way just by using the layout on the page to tell us what each thing is. So you notice I've lined up all the x1s here. I've kind of crookedly tried to line up all the x2s and then our x3s as well over here. So if we just know that the first column goes with the x1s, we can write this in an augmented matrix form. So the first column represents the x1s. The second column represents the x2s. I don't have an x2 in the middle row, so I have a 0 there and a 7. And then for the x3s, we have 3, 4, negative 5. And then to the right of the augmented bar, we have the terms that did not have any variables. So what we end up with here is we started off with a vector equation. We've also written this as a system of equations, or a system of scalar equations. We've also written this as an augmented matrix. And depending on our context, it's going to be useful to be able to use all 3 of these different representations of the same thing.